Hi everyone, welcome back to my channel. In this video, we will be looking at the problem of to reverse a number which is entered by the user, or we will be solving a similar problem on Leetcode, and we will be solving all the test cases and edge cases which are there and which we have to look upon it. So let us get started. So as the problem statement states, reverse integer, we have been given a signed 32-bit integer x, return x with its digits reversed. If reversing x causes the value to go outside the signed 32-bit integer range, then return 0. Assume the environment does not allow you to store 64-bit integers, signed or unsigned. So we came across two words, right? Signed, unsigned. What does it mean? So signed number means it will include both positive as well as negative, and unsigned will include only positive numbers, right? So what is the problem stating that suppose x is equal to, let us say x is equal to 15. Okay, so after reversing it should be 51. If x is equal to minus 121, after reversing it should be minus 121. If x is equal to minus 150, then after reversing it should be minus 51. Okay, so what will be our approach? Initially we will be checking if x is 15, if x is greater than 0 or x is less than 0, and upon that condition we will be passing a function to reverse the number. Okay, so actually what is the core logic how to reverse an integer? So initially suppose the integer is suppose n equal to 15. Okay, we will be using a while loop. Suppose while n is not equal to 0, remainder is equal to modular of 10, and the number that is the reverse number equal to number, initially it will be 0, right, into 10 plus remainder, then n equal to n divided by 10. So this we will be iterating until n is equal to 0. Let us dry run this code. Initially n is 15. 15 is not equal to 0. Now 15 modular 10, which means 15 modular 10. Modular means remainder, so remainder is 5. So number is initially 0. So 0 into 10 plus remainder is 5. So it is now 5. Now n by 10 means this one quotient, right? And modular means remainder, so n is now equal to 1. So now the control will be coming here and it will again check n is not equal to 0. Yes, n is now 1. So 1 is not equal to 0. 1 is not equal to 0. Again it will come inside the while loop and it will find the remainder. 1 mod of 10 means 1 mod of 10 means the remainder is 1, and number is now 5 into 10, which means 50 plus remainder, which is 1, 51, and n by 10 quotient is 0, right? Quotient is 0, 0. Now it will again come and check, is it not equal to 0? No, it is equal to 0. Now it will stop the execution and it will return the number which has been reversed by performing all these modular operations, right? So which is 51. So it will return the answer. So let us look at the solution. Initially the function will be starting from here, reverse int x. X is the input, so we have initialized count 0 and temp and temporary variable. So we have used long int. because while reversing it might be a case that we might cross the range of integer. So that is why we have taken long int which will store 64-bit integers, right? So the input x, if x is less than 0, then we will increment count. I will say you why we are incrementing in the later. You will get to know why I have incremented. So we will store absolute value of temp, which means if that input is minus 120, temp equal to absolute of x means plus 120. So ans equal to func. This is function. We have passed the value of temp. Now the control from here, it will go directly to here, which will execute the function. And inside the function, we have given the core logic of reversing a number, which I have discussed just now. That is this logic while loop, and it will return a number, and we will check if count is greater than 0. Greater than 0 means count negative number is there, and ans, that is the returned value of the function, if it is greater than the minimum value of integer range and if it is less than the maximum value of integer range, then it will again return that answer in the negative form, right? See, in the example 2 you can see, if x is minus 123, it should return not 321 but minus of 321. So it will return that minus of ans. So upon that we will return ans, and if it is the ans that the function returns, if it is greater than the maximum value of integer range, then simply we will return 0, because it's clearly mentioned, if reversing x causes the value, see, if reversing x causes the value to go outside the signed 32-bit integer, then return 0. Similarly, that I have implemented in code. This line, see, if reversing x causes the number to go outside the signed 32-bit integer range, then simply return 0, which means if ans, that is the returned value of the function, greater than the range of 32-bit signed integer, then simply return 0. So after that we have written the ans. Let us run the code. Okay, it's working fine. Let us run all test cases. Okay, it's working fine. Let me explain the logic once again. What we have done, we have simply taken n equal to 5. We have taken input and written 51. If it is negative, we have written minus 51. Simply. Let us submit the solution and check whether it's working or not for all the test cases in the backend. So yeah, it's working fine. Runtime is 3 milliseconds faster than 69.68 of C++ online submissions. So if you really like this video, please subscribe my channel and share it with your friends. Thank you.